What's up, everybody? This is your boy Tech G back with another video to help you successfully pass the CompTIA Network Plus N10-007 certification. So let's get into it. In this video, you're going to learn about business continuity and disaster recovery concepts such as fault tolerance, high availability, load balancing, NIC teaming, port aggregation, clustering, power management, battery backup ups, dual power supplies, and redundant circuits. Let's talk about fault tolerance. So fault tolerance is the property that enables a system to continue operating properly in the event of the failure of one or more faults within some of its components. If its operating quality decreases at all, the decrease is proportional to the severity of the failure as compared to a naively designed system in which even a small failure can cause total breakdown. Fault tolerance is particularly sought after in high availability or life-critical systems. A fault tolerance design enables a system to continue its intended operation, possibly at a reduced level rather than failing completely when some part of the system fails. The term is most commonly used to describe computer systems designed to continue more or less full operational with perhaps a reduction in throughput or an increase in response time in the event of some partial failure. That is, the system as a whole is not stopped due to problems either in the hardware or the software. Next, we have high availability, and this means that an IT system, component, or application can operate at a high level continuously without intervention for a given time period. High availability infrastructure is configured to deliver quality performance and handle different loads and failures with minimal or zero downtime. There are three principles of systems design and reliability engineering which can help achieve high availability. The first one is the elimination of a single point of failure. This means adding or building redundancy into the system so that failure of a component does not mean failure of the entire system. The next is reliable crossover. In redundant systems, the crossover point itself tends to become a single point of failure. Reliable systems must provide for reliable crossover. And the third is detection of failures as they occur. If the two principles above are observed, then the user may never see a failure, but the maintenance activity must. Next, we have load balancing, and this refers to the process of distributing a set of tasks over a set of resources, also known as computing units, with the aim of making their overall processing more efficient. Load balancing can optimize the response time and avoid unevenly overloading some compute nodes while other compute nodes are left idle. A load balancer may be one of the following. It could be a physical device, a virtualized instance running on specialized hardware, or a software process. It could be incorporated into application delivery controls designed to more broadly improve performance and security of three-tier web and microservices-based applications, regardless of where they're hosted. And it can be able to leverage many possible load balancing algorithms, including round-robin, server response time, and the least connection method to distribute traffic in line with current requirements. Next, we have NIC teaming, so network interface card teaming. This allows you to combine multiple physical network adapters into a virtual NIC, which will then be presented to the operating system as a single NIC. All the traffic being sent from the OS will pass through the virtual NIC and be load balanced across the assigned physical network connections. The benefit of NIC teaming stem from its load balancing capabilities, efficiently breaking up network traffic across multiple connections, better utilizes network resources, ensures the availability of servers, and increases bandwidth. It also helps simplify network configuration. Next, we have port aggregation, also known as link aggregation, and this is the combining of multiple network connections in parallel by any of several methods in order to increase throughput beyond what a single connection could sustain to provide redundancy in case one of the links should fail or both. A link aggregation group is the combined collection of physical ports. Other umbrella terms used to describe the concept include trunking, bundling, channeling, or teaming. Essentially, port link aggregation increases the bandwidth and resilience of Ethernet connections. Next, we have clustering, and this refers to the interconnection of servers in a way that makes them appear to the operating environment as a single system. As such, the cluster draws on the power of all the servers to handle the demanding processing requirements of a broad range of technical applications. It also takes advantage of parallel processing in program execution. Shared resources in a cluster may include physical hardware devices such as disk drives and network cards, TCP/IP addresses, entire applications, and databases. The cluster service is a collection of software on each node that manages all cluster-specific activity, including traffic flow and load balancing. The nodes are linked together by standard Ethernet, FIDI, ATM, or fiber channel connections. Now, the advantages of clustering are as follows. You have performance. So throughput and response time are improved by using a group of machines at the same time. The next is availability. If one node fails, the workload is redistributed among the other nodes for uninterrupted operation. You have incremental growth. Performance and availability can be enhanced by adding more nodes to the cluster. You have scaling. Theoretically, there is no limit on the number of machines that can belong to the cluster. And then you have price and performance. The individual nodes of a cluster typically offer very good performance for their price because clustering does not involve the addition of expensive high-performance processors, buses, or cooling systems. The cluster retains the price performance advantage of its individual members. Next, we have power management, and this is a feature of some electrical appliances, especially copiers, computers, CPUs, GPUs, and computer peripherals, such as monitors and printers that turn off the power or switches the system to a low power state when inactive. In computing, this is known as PC power management. Power management for computer systems is desired for many reasons, such as the reduction in overall energy consumption, prolonging the battery life for portable and embedded systems, a reduction in cooling requirements, a reduction in noise, and a reduction in operating costs for energy and cooling. Then we have battery backups and ups, or uninterruptible power supply. So an uninterruptible power supply, this is an electrical apparatus that provides emergency power to a load when the input power source or mains power fails. And ups is typically used to protect hardware such as computers, data centers, telecommunication equipment, or other electrical equipment where an unexpected power disruption could cause injuries, fatalities, serious business disruptions, or data loss. And ups differ from an auxiliary or emergency power system or standby generator in that it will provide near instantaneous protection from input power interruptions by supplying energy stored in batteries. Next, we have a dual power supply, and this is a regular direct current power supply. It can provide a positive as well as a negative voltage. It ensures stable power supply to the devices as well as it helps to prevent system damage. Many electronic circuits require a source of DC power. A dual power supply is used to power the electronic as well as electrical equipment. The dual power supply provides positive as well as negative potential with the ground. Many electronic circuits consist of tubes or transistors, and they require a DC power source. And then we have redundant circuits. So redundant circuits, also known as network redundancy, this is the process through which additional or alternate instances of network devices, equipment, and communication mediums are installed within network infrastructure. It is a method for ensuring network availability in case of a network device or path failure and unavailability. As such, it provides a means of network failover. Typically, network redundancy is achieved through the addition of alternate network paths, which are implemented through redundant standby routers and switches. When the primary path is unavailable, the alternate path can be instantly deployed to ensure minimal downtime and continuity of network services. So in summary, this was my quick little class on business continuity and disaster recovery, where we talked about fault tolerance, high availability, load balancing, NIC teaming, port aggregation, clustering, power management, battery backups and ups, dual power supplies, and redundant circuits. Now, if you felt like you've gotten something valuable out of this information, go ahead and hit the like button, share button, drop a comment, but most importantly, subscribe to this channel. Also, go check out my website, Technology G, so that you can get read up on the latest and greatest to help you successfully pass the CompTIA Network Plus N10-007 certification. And until next video, ladies and gentlemen, peace.